So that means that this example, since it's without, must be dependent events. So that's how you figure it out. If it's with replacement, it's independent. If it's without, it's dependent. Meaning the probability of one affects the probability of another. Oh, you weren't finished? I'm so sorry. Yeah, just do that if you're not. And I try to move on and say, well, no, like it's going to hurt my feelings. I've been teaching for 23 years. I don't have any feelings anymore. No, I'm just kidding. I do. I had one class convinced that I didn't have tear ducts. Oh, no. That was terrible, yo. I don't know why. I was something about like, no, I can't cry. They're like, what? I'm like, yeah, I don't have any tear ducts. Yeah. It went on for almost the whole school year. It was great. Oh, were you done? Okay. Here we go. If the pointer below is spun twice, which I guess I really need to draw in a pointer. Here it is. So it's like one of those things, I don't know if you've ever played the game of life or something, and you gotta spin it or flick the spinner. And I hate those things. It always ends up hurting my finger. So if the pointer below is spun twice, find the probability that the pointer lands on gray, then green. So probability of gray and green. Now, there's really no with or without replacement here because if I land on gray, it doesn't mean I can't land on gray again. It's a spinner. So these are definitely independent. It's with replacement because if I land on gray, I can land on gray again. These are not the same size. So on my screen it looks gray. Up here it looks, I don't know, something. But that's supposed to be gray. This is white and that one up there is green. So based on the size, I'm going to use like little numbers. So this would be 1. This would be 1. And then compared to these, what is the number that should go in the gray piece? Based on the sizes. 2. Because the gray piece is twice the size of the green and the white piece. Or another way you could do this problem is you could split it up into equal parts and then just count them up that way. That also works. You're still going to get 2 for the gray. So this is an and problem because you're spinning it twice. So gray and green. So let's see. Arthur, what's the probability that you get gray? Count up the grays out of the total. Sorry? There's 4 total. How many are gray?
2.
2. Okay. Yeah, it's so hard. I had no idea until this year how much I actually read lips. But yeah, 2 over 4. Times, now Mardarius, what about green? 1 over 4. Now when you're multiplying, you should reduce. So 2 over 4 is the same as 1/2. Now you don't have to reduce first. You can reduce at the end. It's just easier usually if you reduce first. So multiplying, Angela, what do you get?
1/6.
Close, you're multiplying. 2 times 4.
8. 1/8.
Yep, good. Very common. Plus I do that stuff all the time. You should see my checkbook. Okay, green on both spins. So probability of green and green. So Alexia, what's the probability that you spin it and you get a green?
1 out of 4.
1 out of 4. And then Arthur, what's the probability that you spin it again and you get a green?
1 out of 4.
It's still 1 out of 4, that's right. And it's the and problem, so we multiply them together. So, Mardarius, what do you get? When you multiply, 1 times 1 is 1. 4 times 4 is, 12? 4 times 4?
16.
There you go. I get it. I totally get that. Yeah, 16. Okay, good. Okay. The white one doesn't really look super white, so well, that's not good. Try again. There we go. Make that look a little whiter. Okay, notice that these are not all exactly the same size. So I'm going to make them all the same size just by drawing an extra line there. Now they're all the same size. And if you make them all the same size, then you can just put little ones on each one of them. And we're supposed to find the probability that it's green on both spins. So that's green and green. Arthur, how many green ones are there? 3. Yeah, it's not perfectly easy to see, but yeah. This one, and this one are supposed to all be green. Oops. So yeah, that's 3 out of, Angela, what's the total?
8.
8. And so times green again, so it's still 3 out of 8. That will not reduce. Alexia, when you multiply it, what do you get?
9 over 64.
Yes, good. 3 times 3 is 9. 8 times 8 is 64. Okay, what we're going to do is we're going to finish. There's very little left, but we're going to finish this up Monday, and then I'll give you the assignment, and you can work on it in class. If you weren't done with that, that was 9 out of 64.